you need to scan this pixel. People are more interested to have a beautiful image in a small space with the eye tracking system. You can follow the image.
So the future, lucky you.
Probably, yeah, I don't know.
Hi everyone, welcome to this new episode of XR Café, a series of interviews with XR leaders. Today I'm very happy to welcome Aymeric, who's an optics designer. He has a PhD in optics and laser engineering and is making augmented reality possible today. Thank you, Aymeric, for joining me today.
Thank you, Oscar.
Cheers.
Cheers.
Right, so the first question is, you got this PhD in optics. How did you get to do a PhD in optics? Were you passionate about physics? What brought you to this?
So yeah, basically, what I liked before it was physics, all physics, and step by step, I used to be very passionate by optics. And what I wanted to do also, it was to do medical studies. So I was interested by the both, but you cannot do the both. So basically, I do some internships and so on, and I learned a lot about something which is called biophotonics, which is optics applied to biology and to medicine. And after that, I found my PhD where I can do the both, so it was almost perfect.
It's perfect, awesome. And actually, since then, because actually it's been many years you got them already, what kind of optics have you been focusing on?
So my PhD was about developing a microscopy tool in order to track and to understand the early stage cancer. And the idea was to use optics. So the idea was to just take pathological samples and to study and understand how cancer are developed inside the tissues. So it was a very cross interaction with medicine and with optics, but basically almost optics because the idea was to design a full microscope, plug and play, and available and easily to use for biologists. So it was something also to have a cool design and also to have something like fancy and super easy to use. So a bit of hardware also. So yeah, pretty
awesome.
cool.
And after you told me you worked in the defense or a special industry with Ariane, can you tell us more about this because it's quite interesting as well?
So yeah, during almost 7 years, I used to work a lot on R&D works for academia and for let's say almost an institute research group. So I used to work a lot on medicine and biotech technologies. But at the end I wanted to more go to companies because I was always frustrated to just be stuck on R&D, and after I wanted to have a direct product application. So and what I used to like when I used to work for special and defense industries is that you design something, you imagine, you design, you simulate, after you can prototype, and in few months you can have the product. And it was something that I really used to love so in my work here.
Awesome. And now actually you work a lot on AR glasses, right? You told me that's one of for the past couple of years, it's been one of the main needs that you got from clients and from companies you work with, right?
Yeah, exactly. So I used to work at the same time in special industry. And at the same time, I had at the beginning I didn't really understood why I have such demands. After I was digging inside this topic, so I was doing some bibliography, chatting with people, trying to understand, simulate, experimenting a lot of simulation for using ray tracing software, and basically it was. Incredible that this world is super wide and super cross-platform interaction, and it's something like you can apply simulation to direct industries, and also the market for these technologies is super already developed. So you have a directly prototype phase that you can reach very easily at the end. So
awesome. Actually, for those who are not familiar with waveguides, because waveguides is one of the main technologies used for having AR glasses, basically having a display in front of your eyes. True. on the real world, let's say, without a display. Can you explain in let's say regular people terms how does the waveguides work?
So yeah, basically the waveguide, as the name is said, is just to guide the
wave.
light, the wave, so the light basically. And after there are a lot of type of waveguides. At the beginning, it was only, for instance, two reflective surfaces, and the light just was bonding inside the two glasses, and it was shaped and after directed to the eye. So it was just the main basis of waveguides. And after, with the new technologies, with metal surfaces, with also light pipes or just waveguides, you can shape the light, but in a very super small surface. So at the end, that's super cool. You can project the light, and after the light is already shaped inside, and after it is directly directed to the eye in the end. So yeah, it is nano. So the waveguide basically it is nanostructure system. So it means that we have a very tiny pattern shapes that is able to shape the input light to something like we can all project with a magnification, with a field of view, and so on. So
Okay, awesome. And actually, a lot of people always think about the optics, but I noticed that something super important is also the projector. Some companies leverage one company for optics, another for projector, and some optics maker actually also provide the projector. So actually, can you explain how important the projector is and what are kind of the main different technologies for projectors?
yeah, no. So I think the main crucial point for AR glasses is almost the waveguides, because it is, as I said, shaping the light in a very small space. So it requires a lot of space, a lot of rooms, and dedicated rooms to shape these optics. Sometimes it is clean rooms, so with a very specific environment that ask a lot of space. Yeah. For laser and for projector, it is a bit easier because basically the idea was to just have RGB light, for instance, or some laser lines, and the idea is to just after project it. So the idea is you can scan, you can scan it, or you can just project it directly. And with that, you need to combine.
And when
with,
you say scan, can you explain it? Because for most people, scanning is like you
yeah.
scan a document, right?
Yeah,
so
for
maybe
sure.
for you, it's a normal term.
But it's almost the same, but not. So when you can project directly the light, the image. So it is, let's say, what almost the easiest projector do at the end. But if you scan, so it means that you have one laser line, and after it add one pixel information, and after you need to scan this pixel. So at the end, you will create an image, but by line. So it is super fast because you need to create the image.
Okay.
You need to create this image, but at the frame rate of the eye. So at the end, it is like millisecond. Let's say scanning, yeah.
Okay.
So
So it does literally like a scanner. It does. That's why you say scanning. Okay.
That's why I say scanning. And the key advantage of that compared to directly projecting the image is that when you project directly the image, you have a lot of distortion, aberration, and you need to have a perfect combiner to. So you have a lot of pressure on the combiner and the waveguide and so on to remove all this aberration, distortion. That can be quite tricky because you need a lot of you need more space. And this is difficult to handle at the end. But when you have a pixel scanning, so first you can decide where the pixel goes. And also you can directly artificially, that the eye has a specific field of view. And you can just remove a part of the field of view artificially, but just removing the pixel and so on. So at the end, you can really also follow with the eye tracking system. You can follow the image directly with the scanning. So it is easier to handle at the end.
Okay, and so the most common it's more like the projector, right, than the scanner at the moment. It's what is most commonly used?
No. Basically, right now, there are a lot of scanners in the market and for products, simply because you have less pressure on the waveguide, so you can have a more basic system. but with scanner, after the problem with scanner, it is a computational loading because you need to give orders at nanosecond time scale to have any scanning projectors, units. But the first application was directly the projector, the full projector.
So you think in the future is scanning technology the one that's going to be moving forward?
Because you have all this potentiality by just reducing the industrial also cost of this system.
Awesome, thank you so much for sharing. And I was going to say, next question, as a professional designer of optics, can you share actually with what's not under NDA, because there's a lot of NDA in that space, what kind of client project use cases actually you get to work for? Is it more military because in a plane you need to have like a visor in front of your face? Is it more actually consumer AR glasses? What kind of projects do you get?
My first project was for a defense application. So it was, for instance, to project images on the helmet for plane drivers, let's say. And also to project some images on the cockpit. But at the end, now it is more for entertainment or for AR glasses.
More consumer.
It's more consumer. I used to have some use cases for HUD for cars. For the famous
on the windshield,
maps.
right?
Exactly. It was exactly this kind of things. So. But at the end, the technology is not that difficult. So
now it's more common.
But what I used to like with AR glasses and consumer, let's say, application is that you handle the full project. So you need to create the combiner, but usually it is, as I said, it is basically always associated to the projector. It is not like you take one projector, one combiner, and you just pray that it works. You need to shape one with the others. So at the end, you can handle the full project. Then the full hardware of this thing. So it's
okay, great. And actually, as you may have seen, I did a table where I compared all the optics and I was diving into all of them, and I noticed there are some strong leaders like Lumos, Celed, if I pronounce it correctly, Magic Leap also for the optics, and even a French one, for example, Optinvent. And from a technical point of view, actually, with all of your expertise, which one you feel has been the most impressive to you, and which one do you feel actually is leading the space moving forward?
What I understood is that Magic Leap is taking a big step with new applications. With the new technologies implemented, they try to succeed. They succeed to let's say to enlarge the field of view and also the image quality. That also is the main criterion. What I notice is that people are more interested to have a beautiful image in a small space than having a very big optical performances. That is more quantitative things that the eye is not able to really target. To notice. So that's why Magic Leap, I think, understood this aspect much more. While the other companies try to have the best optical performances, that is maybe a lot of pressure on hardware since you don't really need it. So.
Okay, very interesting. And I was gonna say, did you see? Because actually yesterday I learned about. Let me check. I learned about the new lens from Lumos, the ZOE 70 with at least 70 degrees of field of view. Have you heard about it? Because apparently they announced it in June, but we don't yet have all the specs. We don't have the thickness, we don't have the brightness, we don't have the weight. But apparently they can even do 2K per eye, so it's pretty high. Is it something that also is a breakthrough? Because from just the charts I've been making, they seem to have been able to do. Actually, they announced to be able to do 75 and plus. and so which is even higher than the latest magically publicly optics of 70.
Okay.
Is it an achievement, or for you, no, it's doable? What is your take on this?
I think we need to pay attention to the optical performances and the image quality. That
Okay.
is the more demanding aspect for
So
the customers.
basically, if you have an amazing field of view, you may lose on other things that are super important. So sometimes it
Probably,
might be
yeah.
better to do smaller field of view, but then you have maybe better brightness, maybe lighter. Okay.
To me, yeah, this
Okay.
is one key aspect for the consumers. Yeah.
Another question I had is last time we chatted actually for the first time last week, so we met recently, and I noticed when we chatted, you told me that the currently available optics in most AR glasses to you were actually quite old technology. They were not necessarily like breakthrough. Can you explain more on that? Because I think I was surprised. You tell me like it's doable, it's fine. I was like, really? Like I thought it was like a proper challenge. So yeah, why is it actually regular? Like why is it not such so new, and how come it's actually already been there for a while and we didn't know about it?
Yeah, when I say that, it is because I used to work a lot of on R&D companies, so I used to see a lot of innovative technologies and applications that is, let's say, 50 years ahead. And
You saw the future. Lucky you.
probably, yeah, I don't know. But basically, what I noticed is that when you go to market and to direct application, you see that the technologies is like, but I know we can do better, but actually we are like 10 years just late compared to what R&D is doing.
It's capable of okay.
Yeah. Also, basically, what do R&D works? It is like they used to. They develop a lot of things, innovative tools, but it is difficult to translate it into market and to industries because it is super expensive, because it is not even a prototype. So they need to reduce a lot of specifications, and at the end they just go backward. And at the end they say, okay, we have this guy, but in case in their pocket companies keep something like, but we know we can do better, but right now we announce these kind of things.
Actually, I don't know if you read the last article from Carl Guttag. For those who don't know, Carl Guttag is a leader into the hardware and the optics. I don't know actually what his history, but he's really well known and has amazing analysis to share. And in his last article, I was reading it actually yesterday, he was saying that Meta has their own waveguide technology that are very advanced, but they leverage the Lumos for the last device. And he was saying actually it's quite surprising because they kind of used a less advanced technology than the one they probably have internally, but just in terms of cost, in terms of industrialization, it's probably a better a choice in terms of hardware. So it's interesting what kind of trade-off can be made because they are doing it internally, but they still leverage an external partner to do it. And actually, I was going to say, so at the end of the day, is the actual challenge with this technology, with this high-end technology, just to be able to industrialize it and basically build it at large scale with lower cost? Because I'm guessing maybe the amazing one are handmade and maybe they cost thousands of dollars every time. Is that about it? Is it the real challenge?
Yeah, because so for me, from my optical designer point of view, it's that we can simulate everything.
You can see what?
We can simulate everything.
Simulate everything.
And we can, everything is
possible.
It's possible. But when after you just look at the specification, you say, but it is not realistic. And that's also the point I like when it's not only doing simulation, it is also have cross interaction with other people, like mechanical guys, with computational guys. And at the end they have their own specifications, they have their own aspect of the reality, and after you just and after you just have to merge everything, and you need to make something real. So you have the design, you have the simulation, and you say, I have that, I have these performances, it's great, we can move forward, we have a very innovative system. and after the mechanical guys can say, oh yeah, but we cannot produce at this limit, it is too small, we cannot do it. So please relax this guy, relax this constraint. Okay, so I relax, but the performance is going down and so on. And at the end, you just face the reality when you do optical design, and this is very iterative loop. And at the end, we are able to produce something real, but with lower performances that we already
to do some trade-off.
All the time, yeah. So that's why when we go to industrial phase, basically it is a lot of hours, a lot of days, weeks, months, sometimes years to just produce something that has the lower performances that we already target because of the cost, basically, and also just the physical limits.
Okay, awesome. Thank you. Super clear. Before we wrap up, what would be, if anyone wants to reach out to you, because you also work as an independent consultant, what would be the best way to reach out to you? Is it LinkedIn, your email? What's the best way? If anyone wants
for sure. So you can contact me on LinkedIn.
Okay.
And mostly LinkedIn.
I will put the link so people can reach out. Cool. Exactly. Thank you so much, Aymeric.
Thank you, Oscar.
Pleasure. We're going to wrap up. Thanks a lot, for replying to all these questions, giving great perspectives on optics. I hope the sound is good because we got a bit more people joining us recently around in the cafe. It's a real cafe. It's not a setup, as you can hear. Thank you all for watching. Please leave a comment if you enjoyed. If you have a question for Aymeric, for myself, and if there's anyone or any topic you would like to hear next, I'm happy, to get your comments. So all right, thank you so much, Aymeric. Have a nice day and see you at the next episode. Bye.
Bye.